the beginning of matrices, I told you, maybe, that a matrix always has these brackets, right?
Yeah.
A determinant, if you ever see what looks like a matrix, but the lines look like this, it means it wants you to find the determinant. Okay, it doesn't mean absolute value of the matrix or anything like that, but if you ever see straight lines with the matrix, that means the determinant. Okay, and if I have a matrix, A, B, C, D, do this, a matrix A, B, C, D, to find the determinant, I'm going to multiply A times D, those two diagonals, and I'm going to subtract the product of these two diagonals. So 2 by 2 is pretty easy. If I have a determinant, if I have a matrix that's, let's just go 3, 2, 1, and negative 7, and I'm finding the determinant, I'm going to multiply 3 times negative 7 and subtract 2 to get negative 23. Okay, so where you're going to mess up on these is adding negatives. Hopefully everybody knows how to do them. You just have to take your time and make sure that when you subtract a positive number, you're making it more negative. Okay, so the 2 by 2s are pretty easy. 3 by 3s aren't difficult, they just take a little more time. And there are a couple of strategies to do a 3 by 3. And I think I'm going to just teach you the easiest one. If you ever see another strategy, just remember they both give you the same answer. But the way I'm going to teach you, I think, is the one that is the most straightforward. Okay? So let's do the determinant of a 3 by 3. Come on, pen. Come on.
Why, it was just working.
I know. This is my life. Story of my life, yes.
I'll take you home.
Okay, we're going to do a determinant of this 3 by 3.
Okay, so we're going to take 1 times 0 times negative 4 and that.
Okay, so the first step in doing a 3 by 3 is repeating the first two columns at the end. Okay, so I'm going to just go 1, 0, negative 1, 2, 0, 3.
I'm confused.
I repeated the first two columns at the end. 1, 4, negative 1, 2, 0, 3. I repeated
There you go.
the first two columns at the end. Okay, are you with me so far on this step?
Yeah.
Okay, make sure when you're doing this that you're writing very neatly and you're keeping it organized. Because what you're going to do is you're going to take these 3 diagonals first. 1 times 0 times negative 4 is what?
Negative 4.
1 times 0 times negative 4 is 0. Come on. 0. 0. We'll have to use the mouse because I can't do it any other way. 0. 2 times negative 2 times negative 1. Positive 4, right? And negative 3 times 4 is negative 12 times 3, negative 36. Okay? Then you're going to subtract. And I always put it in parentheses. so I don't mess up, yes. And we're going to subtract. See if it'll work now. This, yep, this.
Hey, that's like Japanese math.
It's always subtract. Well, maybe because this number was negative, and then negative times a negative is a positive. Okay, so negative 3 times 0 times negative 1, 0, right? 1 times negative 2, negative 2, times 3, negative 6. And 2 times 4, 8, times negative 4.
Negative 32.
Okay, so on the left I have negative 32, right? This ends up being negative 38, right? And I'm subtracting the 2. So negative 32 plus 38 is 6, yeah.
Negative 32 plus negative 1738.
Negative 32 plus 38 is 6. Okay, it just comes with practice, and you just have to be really precise with your numbers, making sure your rows and columns are very neat. Go ahead and take a pencil when you're doing it and just draw your 3 diagonals first, multiply those, write them down, subtract parentheses, draw your 3 diagonals the other way, multiply those, write them down, and then simplify.
Can I take a photo of that?
This recording will be posted as well.
So am I going to find the determinant on because they have their brackets instead of straight lines.
What does it say?
It says if A bracket all the numbers, then DETA.
That's the determinant of A. Okay. One more thing I want to talk about. You can use determinants to find the area of a triangle if you're given 3 points on the triangle. And many times, I'm just going to I'm going to make up 3 points. 6, 7, 6. And let's go down here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, I'm just making up a triangle. How do you find the area of a triangle? Who remembers? 1/2 base times height. 1/2 base times height. That's the area of a triangle. Okay, so for me to find the area of this triangle, I've got to find the length from here to here. Then I've got to find the perpendicular height, figure out that point, find the distance between them. It gets pretty convoluted, right? If I'm just given 3 points. You can use determinants to find the area of a triangle without having to do all of that work. Okay, and to do that, maybe, thank you, the area of the triangle, hello, equals plus or minus the determinant of, you're going to put the x's, it doesn't matter the order, in the first column. You're going to put the y's in the second, but they have to match the same coordinate point. Okay, so this would be 6, this would be -4. With me so far? Just putting the x and y's. And then you're just going to come down with 1s.
Why are we coming down with 1?
That's the rule. That's how you do this. I'm trying to explain how you find the area of a triangle using determinants. And this is the process. And it's actually plus or minus 1/2 times the determinant. Okay, so let's find the determinant. 2, 2, 1. Huh. Come on. Where's my eraser? There you are. 7, 6, 1. and 6, negative 4, 1. So remember, to do this, repeat right?
It doesn't matter how you started out.
Well, I'm always going to do, actually it does matter. This goes first. Yep. Go left to right first. So 2 times 6 times 1 is 12. 2 times 1 times 6 is 12. 1 times 7 times negative 4 is negative 28. I'm going to subtract. 1 times 6 times 6 is 36. 2 times 1 times negative 4 is negative 8. 2 times 7 times 1 is 14. With me there? 12 plus 12 is 24, minus 28 is negative 4. And inside here, I have, what, 50 minus 8? Is that right? So negative 4 minus 42 is negative 48. Okay? Can the area ever be a negative?
No, it's not.
No.
46.
Oh, yeah. Can the area ever be negative? No. This is why it's always plus or minus. Okay, so I've got to take 1/2 of this, and I'm going to take it by negative 1/2 to make it positive. Or you could just think of this as take the absolute value of this and divide it by 2. Okay, so the area of this triangle is 23, whatever the units were, squared. Just take the absolute value of the determinant and divide it by 2. And that gives you the area of a triangle when you're given 3 points. Okay, so we've learned how to do a 2 by 2 determinant, a 3 by 3 determinant, and then the area of a triangle when you're given 3 points in the coordinate plane. Okay, tomorrow we're going to utilize determinants in solving systems of equations. Okay, so now you're going to see why there is a value to matrices when you're doing 2 equations, 2 unknowns, 3 equations, 3 unknowns. We can use determinants to do that. Okay, I'm also going to teach you how to do it on a calculator tomorrow. But on the test, at least for the determinant pieces, if there's a 3 by 3 determinant on the test, I need to see work like that, not just that you used a calculator. You can use the calculator to check your answer, okay, but you still need to know how to do it manually. So I would practice using WebWork, because I think in the section they do show you how to do it in the textbook, how to use a calculator. Yeah. So if you want to follow that and check your work in WebWork, but I would do your work in WebWork manually and then use the calculator to check it, just so you're ready for the quiz. And the quiz will be on Wednesday. And it'll cover through tomorrow's lesson. Okay. Let me go through the textbook check real quick. The determinant of a matrix, as represented below, is AD minus CB. AD minus BC, either way. So it's that first one. The easiest way to begin to find the determinant of a 3 by 3 is copy the first 2 columns to the right of the last column. If you wanted to find the area of a triangle with these coordinates, you could create a 3 by 3 matrix where the first 2 columns are the x and y coordinates and the last column is 1s. The determinant of this matrix is 9 minus 16 is negative 7. And in page 1 of the textbook, there's a description of how to find the determinant using a graphing calculator. That is true.